Hello,
Yes, sir. Yes, sir.
hello. Am I audible?
Yes.
Hello. Okay. Good evening and good morning to all of you.
Good morning.
Hello. Okay. We have learned about the some basic concept of the hydrogeology. Now we will see today the modeling part of this, and we will see the some modeling related to Modflow modeling, and we will see how to form a grid in boundary condition, and we will see the Modflow modeling for the confined and unconfined aquifer. Then before starting this modeling part, we have to learn some basics things like what is the hydraulic head, what is the piezometric surface, what is the concept of the confined and unconfined, and after then we will learn aquifer testing. What is the aquifer testing and which method we will apply suitable best method for the aquifer testing, and on how to identify this aquifer is a unconfined, this aquifer is confined, and this is a burst type of aquifer. We will see. Okay, with and I will share the recorded video today late night or to till tomorrow. Don't worry about these things, and I will share the all the notes related to this and code. The first things we are going to learn about the hydraulic head, and after then we will do some modeling work on Python. And have you installed the Python? If you have any problem during the installation process, have you any problem? Okay, now I'm going to share my screen to all of you. Now, first to understand the what is the basic concept of the hydraulic head. The general definition: hydraulic head or piezometric head is a specific measurement of liquid pressure above a vertical datum. Then, if hydraulic head and piezometric surface is the same thing. Okay, piezometric. This another name is the piezometric surface is another things, and piezometric head and another name of the hydraulic head is called the piezometric head. Okay, next things, it is usually measured as a liquid surface elevation expressed in units of the length at the entrance or bottom of a piezometer. This will be more clear. In an aquifer, it can be calculated from the depth to water in a piezometric well. A piezometric well specifies the type of the water well. We will see when we will call this a piezometric well or flowing well. We will see this thing. And given information of a piezometer's elevation and skin depth, hydraulic head can similarly be measured in a column of water using a standpipe piezometer by measuring the height of the water surface in the tube related to a common datum. The hydraulic head can be used to determine a hydraulic gradient between two or more points. This difference has been taken from the Wikipedia. Now, general equation for the hydraulic head. P1 is a pressure head of this is the rho V1 square. This is the kinetic head, and rho GH1. This is the gravity, and this is the height. This is the your potential head, and this is generally follow the Bernoulli's equation. It is a balance equation. Okay, the general equation for the hydraulic. The combination of these three is called the hydraulic head. And this is the curve for we will not go in deep, just read out this curve. Pump is a hardware, okay, which feeds energy to fluid, example water, to flow through a channels. In any practical application, the pump needs to work with its best performance. It is also important to check the fuel flow rate and head of the pump are within the required specification, which are normally presented as the pump characteristic curve. These plots may important role as an understanding the region which pump needs to be operated, thus ensuring the life of the pump. Okay, and this will be more clear when we will read about the pumping test with Thayer's equation and the Coulomb equation. This will be more clear. Now we will explain one by one what is the pressure potential. Pressure head, it is also called a pressure head. The pressure head represents the flow energy of column of fluid whose weight is equivalent to the pressure of the fluid. Okay, this is the called the pressure head. Okay, and when you will simplify this thing, then integrate, then finally this one, this is the pressure of water, this is the pressure of the atmosphere. Now next, the elevation potential. Elevation potential head. The elevation potential head represent the potential energy of a fluid due to its elevation above a reference level. Okay, 1 by m. 0 to z. Z is elevation starting from the ground level. M g days, and finally m is the mass. And finally, after the integration, this will give the gz. G is gravity. Z is elevation. Kinetic potential. The kinetic head represent the kinetic energy of the fluid. It is the height in a feet or in meter. It doesn't matter if you're taking about this CGS, MKS, and FPS. Their measurement system. Generally, height taken in the FPS, foot, poundal, and second. In feet, that a flowing fluid would rise in a column if all of its kinetic energy were converted to potential energy. And this is the equation. Okay, when you will simplify with the integration, then you will find the v square upon 2. Okay, finally, and this combination of this p by rho plus gz plus b by square by 2 is called the hydraulic head. But question is that we consider only gz, not we will consider this one, and not we will consider this, because in the flowing water inside the earth, in the case of the groundwater, this is negligible and this is negligible, because the water is in groundwater, water is present in the pore spaces and the stagnant type. It's a very low small quantity. So we will, for modeling purpose, we will only take consider about this thing, elevation potential, and this is called the hydraulic head. Now total potential, how to call this is the total potential p by rho, gz. G is the gravity, z is elevation, and this is the your velocity, and the unit is this meter square per second. Okay, total hydraulic head, when this is divided by your gravity, it's a total potential, then this is converted into hydraulic head. That's why hydraulic head unit is meter. Okay, 5 by z, and this is the unit, and this is the unit. Only J is considered. Okay. Now this is the pressure head, this is the elevation head, and this is the term head, and this is considered as a negligible. This is considered as a negligible in the case of groundwater, because this is a very small amount. Only we will consider about the elevation head. This will be more clear. I want to show how to calculate. Uh, this is your ground surface, okay, and you are standing here, and this is your well, and this is water level, okay, and this is your datum plane, and this undulatory surface is bottom of the your aquifer. Okay. Now from here to here you will measure, this is something x, okay, and this from datum plane to here, this height is called the height from mean sea level, okay, this height is called, okay. Then the your elevation head is, suppose that this is a d and this is a x, then elevation head is equal to d minus x. Then this gives the in meter, okay. This is generally this is called the in meter or feet, okay. And this is your elevation head, or it's generally called the hydraulic head, because we will negligible the pressure head and this one pressure head and kinetic head we will neglect. Now hydraulic head H is defined as H is equal to HP plus HZ, where HP is a pressure head and HZ is your elevation head, where HP is the pressure head and HZ is the elevation, and all three quantities have the dimension L. But we will negligible the this one kinetic head, okay, because the movement is the very slow. But we will also neglect the pressure head, only consider the elevation head. Now pressure head, we will talk about the pressure head represent the energy due to pore fluid pressure. Elevation head, the elevation head represent the gravitational potential energy arising from the elevation. Kinetic head, groundwater velocities are so slow, kinetic energy is typically negligible. Water flow from high to low, hydraulic heads along a hydraulic gradient. And this is the instrument uh, for
सर
measuring
एक
your height from water level to ground surface. And this is a tip point when this portion come to the contact of the moisture. It means when this will touch the water table, then a sound is coming beep beep, and you just read the reading. In situ measurement of a hydraulic head is accomplished by the measuring of the water level elevation in wells. First, the depth of the groundwater is measured with the aid of a manual tape, electric sounding instrument, pressure, transducer, or similar devices. Next, water level elevation are obtained from the separating the major depth to water from the land surface elevation. In region where spatial hydraulic head difference are slight, typically in areas of a gentle topography. The conclusion of this statement is that hydraulic head for unconfined aquifers follow the topographic elevation. How this will be? This will be more clear. So I have explained how hydraulic head can be calculated: mean sea level height from the elevation from the land to the water level. Okay. See, this is you can clearly on this picture. Okay, this is called the pressure head. Okay, this will be more clear. And the altitude, and from here this is the datum plane, and from here to here is called the mean sea level height. Okay, and from this pressure head to elevation head, the bottom of the pressure head to elevation head, this head is called the your elevation head, and this is called the your pressure head. Okay, the actual water level height. Okay, and the kinetic head is the flow of water from this when the head loss. See the height of this. Someone is asking question. Just wait, I have to read. If two groundwater depth taken as a 120 meter below groundwater level in Rajasthan and 2 meter below groundwater in Kolkata, and their DM value 200 meter and 1 meter respectively, then what is the elevation head or hydraulic head? Okay, I will clear this. I will show you. First, see. Okay, this is the datum plane, and from datum plane to the actual ground surface is called the mean sea level height. Altitude are the measurement point. This will called. Okay, and what is the elevation head? Elevation head is the from distance, vertical distance from datum plane to the bottom of the column, water column. This is the called elevation, and the actual height of the water column is called the pressure head. Okay, then only the this one is called water column is only called your this hydraulic head, because we will neglect this elevation head and kinetic head we will neglect. And this is the unconfined aquifer, and you know the unconfined aquifer is follow the topographic elevation. And here the height of this water level at 90 meter, here water level at 80 meter, then water will move from here to here, then this is called the your kinetic head. Okay, groundwater flow movement. Hydraulic is a total mechanical energy per unit weight. Okay, finally this we have seen how hydraulic head this is potential energy depend on the your height of the this water level and gravity. Okay, it is clear. Now someone asked me this one. Someone else, the height. If water groundwater depth taken as a groundwater depth taken as a 120 meter below groundwater level. So first, this is the ground surface. Okay, and from here, some place name is Rajasthan. Okay, Rajasthan, and from ground surface to this has been taken in 120 meter. MBCL, I think this is the meter below groundwater level. This is the meter and below groundwater level. Okay, this and their DM value is 20 meter. The DM value is 20 meter. This is your uh, datum plane. Suppose that, and DM value is given at this location is not 20 meter. This is a 200 meter. Then the actual height from the datum plane is the 200 meter, and this represents the height from the mean sea level, MSL. Okay, Now, next things is that and Rajasthan and 2 meter below ground in Kolkata, and their DM value is 1 meter. Now, suppose that this is the place Kolkata, and this 2 meter, 2 meter below, and 1 meter. DM value is 1 meter respectively. Then this from this. Uh, then datum plane is moving from here to here, and the height is this one. This is the 1 meter. Oh, then emitter. Then what is the elevation head or hydraulic head? Then I have already told you in modeling purpose we will only consider the this pressure head. Pressure head means only the height of the column. Okay, and from here this is the column. This is the your column of this, and suppose that this is the bottom level, and this is the your jet. This is the elevation. Then we will neglect these things. Okay, get this one. Then hydraulic head for this, if you want to consider hydraulic head for this, and you know the this one, this value of 120 meter and 200 meter, then the pressure head plus elevation head is equal to, this is basically pressure head plus elevation head is equal to 200 minus 120. It is 80 meter for Rajasthan, and for this basically DM value is 1 meter, and this is 2 meter. You are below 2 meter, so 1 minus 2 is equal to minus 1. Then its hydraulic head is the minus 1 in meter. It means the it's upper the ground surface. Here the some water level is at very upper the this one piezometric surface. Then it's mean that at this place water is in a flowing stage. We will see what is the meaning of the minus, and see. Okay, then hydraulic head for this Kolkata is minus 1 meter, and for the this one Rajasthan is 80 meter. Now now we were going to do some Modflow modeling, and for this we will I have delivered this lecture yesterday, but I want to quick recap for this Modflow with floppy, and what is the floppy we will see. uh, Modflow and floppy we will see. What is the Modflow? We have seen Modflow is developed by the USGS. Okay, it solve the ground. Basically, it is designed for to solve the groundwater flow equation, and it's a public domain, and that is the free open source software written in the Fortran. And Fortran coding will work in Python. Okay, but some it's paid and not public domain software like Waterloo and GM UI. These softwares are the paid version software. You need to license and you have to purchase. This is your hydraulic conductivity, and this is your head. Then we will see hydraulic. What is the hydraulic conductivity, and we have read about the head. Okay. This is a heat map showing the spatial distribution, the logarithmic of the hydraulic conductivity. Values across a grid. Hydraulic conductivity is a measure of a material capacity to transmit water. The color scale on the right side of this map indicates the range of the log K values, hydraulic K values. Now, what is the hydraulic head? We have discussed in detail. See what represent this picture. This contour map shows the distribution of hydraulic heads. It means so the head loss at different point the hydraulic head is different, which means so that the water is in a flowing stage. Hydraulic head is a specific measurement of liquid pressure above a geodetic datum plane. Okay, the control line represents the location of equal hydraulic head. These lines are close together near the wells, indicating a steep gradient caused by the pumping or recharge, which could mean there is either extraction or injection of water at this point. This is the Modflow relevant programs and how the Modflow will work in the, if a river, basin, and other patterns are present. Many other programs based on the Modflow, so-called the Modflow site. MP3 DMS is package used for the transport package. When you will you want to modeling related to transport, then you have to call this library. Modpath particle tracking. It's basically used for the contamination, seawater, density dependent flow, and transport in coastal aquifers. Peric Henry concept is used, and pre-QC is a reaction type of when the reaction is occurring in your groundwater, then we will use this package. And PEST U code parameter estimation sensitive analysis for this. And the last visual Modflow is a software which is a paid version, GMS, PMWN. These are the not for the your public. This is a software, and it is uh, when you want to use this, then you have to purchase license for this. But you know, simply Fortran coding and Python, then these packages are free, absolutely free in the Python. See how the Modflow will show you day by day contamination in groundwater. See, here the day has changed and contamination, how the contamination increased and simulate the contamination pattern, how contamination is shifted from especially shifted, see, in 2.7 days. And this is the feature. We will set the day for this, and we'll do the modeling for this. And this is the basic equation, and we will use this equation for the steady state equation, where S is the specific storage, phi is the hydraulic head, K is the hydraulic conductivity, Q is source or sink. In Modflow modeling, the first things we have to define the boundary condition of this. It means the grid pattern condition. Okay, we will define, and we will first see the grid pattern. This is called the grid. Okay, and this is the active cell. This is inactive cell inside your grid, where is your targeted is called the active cell, and outside your grid boundary is called the inactive cell. This is written, and you have to given this one dimension of the cell. Suppose that a dimension basically a grid. This square box is called the grid, and you have to give the dimension. Suppose that you want to calculate at grid resolution is 1 meter, then size of the lateral size of this grid is 1 meter or 1 kilometer. This is called the dimension of the grid. Cell size. Each grid cell has a specific size which contains be uniform or vary spatially based on the needs of the model. Cell size. The grid has dimension the x, y, z direction, and cell size is your variable size. A variable which your pH or water hydraulic head or some others like contamination. These are the cells. What is the boundary condition? The grid defines boundary conditions that control the flow of water into and out of the model domain. This we will see in this practical. These include specified head boundaries, constant head boundaries, and no flow boundaries. Constant head boundaries means no flow boundaries, and recharge or no discharge and discharge. And stress periods, which is a time. Modflow simulation are often run for multiple time periods, known as the stress period. The as we have seen in this this video picture, this is a stress period, how the contamination is concentration is going on day by day. Now finite difference equation, and we'll see finite difference equation. Basically the equation so represent the water mass balance for a given cell in a described space, typically used in numerical models such as Modflow in equation, and the summation qi in the sum of the flows into or out of a cell. We will see how results is come. Si represent the storage coefficient of the cell, which is a measure of how much water can be stored in a unit volume of aquifer. And phi, delta phi upon delta t is the rate of the change of the hydraulic head with time, and vi is the volume of the cell, the product of si and into delta psi upon delta t, and vi gives the change in water mass for the cell. Then we will see how the change of water mass, which should equal the sum of the flows into or out of the cell to satisfy the conservation of the mass. Finite difference equation. This is a more equation. We will not go in here, but see overall interpretation of this. The image and illustration uh, of how to calculate the flow between cell in a finite difference model, which is a numerical method used for solving partial differential equation. The first, in Modflow modeling, there are two things. The first thing is that your conceptual modeling, how to construct a grid cell and this. Now, after the construct of the grid cell, then next you have to calculate the uh, this one, how to flow is going on, how to contamination is going on with day by day. Then this is called the numerical modeling, and this is the equation for the numerical modeling, and this is the equation for the previous equation for the conceptual modeling. And not for this is also a part of the numerical modeling. Conceptual modeling is a grid formation. Okay. This is a budgeting water stress budget, and this is the finite difference equation. Is the water moving, how the waters are moving from day by day, or something other variables like pH or contamination. Active cell, and we have seen this cell type. Each cell can be active cell, variable head, inactive cell, outside the domain. Outside the domain is called inactive cell. Then we have to consider only this. Inactive cell is defined by the 0, and active cell is defined by the 1. Flow after discretization. Ultimately, a linear system matrix is derived from a finite difference equation. A phi is equal to f, where phi is a invertible matrix of coefficient and the high right hand side vector. This will be more clear. Flow, mod flow after discretization. This indicates the stage in the modeling processes being discussed. Modflow in a popular software used for simulation groundwater flow. Discretization is the process of converting a continuous domain like an aquifer into a finite number of discrete cell or elements so that the differential equation described flow can be solved numerically. Okay, the difference between the integration and differential, when you split anything in a very small pieces, then you have to use differential equation. When you uh, s- uh, added small pieces, then you have to use integration process. Then basically discretization, you split your aquifer in a very small cell, which you have defined in the process of the this grid formation. Then this is called the method of discretization. And how this numerically this will work. A phi is equal to f. It mentions that after discretizing a linear system in the form of metric equation is derived from the finite differential equation. The equation is presented as this, where phi pressure represent a vector of a hydraulic head in the system, where 1, 2, phi 1, phi 2, phi n are the heads at different points or nodes in the described grid. The vector is denoted as transpose T, indicating that it is a column vector. A represent A represent an invertible matrix of coefficient. Invertibility is crucial as it allows the solution of the linear system by finding the inverse of A, which only exists if A is indeed invertible. Okay, this is the matrix property. Uh, this is numerical parts of the this, and the coefficient A arise from the discretization of the groundwater flow equation and include terms related to the hydraulic conductivity, storage coefficient, and geometric factors of the grid cells. F represents the right hand side vector, which may include terms of the source and sinks, such as well, recharge or discharge area, pond, etc. Now come to the FloPy. Python package for creating running and post-processing Modflow based model, open software environment that combines Python with Modflow side. FloPy can generate input files for the Modflow family programs in a few lines of the code. And this is the installation process. And now we will see some about these things. What is the FloPy?
No.
Uh, Creating a boundary condition for Modflow modeling with FloPy. Introduction to the FloPy package. What is FloPy? FloPy is a Python package designed to simplify the creation and analysis of groundwater models, specifically focusing on the widely used Modflow framework. Importance of the using FloPy for Python. FloPy streamlines model setup, execution, and post-processing, enabling used to efficient build and evaluate groundwater simulation. Overview of key features and capabilities. FloPy provides extensive functionality, including support for various Modflow package data manipulation, uncertainty analysis, and visualization tool. Installing FloPy. How to install the FloPy? Simply use the pip install. Pip, write the pip, and use code the install and use the FloPy. How can you write? Just I'm going to open this one. Pip install FloPy. Okay, now the FloPy has been installed successfully. Working with FloPy, the first loading and running Modflow model, read and manipulate the input files to create Modflow models, then runs the simulation to obtain result. Saving and exporting model results, save the simulation outputs, including water levels, flows, and heads for water for further analysis and visualization. Importing FloPy model, just use the result keyword, import FloPy as floppy, and accessing and manipulating the model data. This is the practical part. We'll see. Advanced feature of the FloPy. Some advanced feature: model calibration and uncertainty analysis. Apply advanced techniques to calibrate model parameter and assess the uncertainties to improve the accuracy of groundwater prediction. Visualization Modflow results using FloPy generate visually modeling representation of groundwater flow and contamination patterns with FloPy powerful visualization capabilities, and coupling FloPy with the other modeling tools, integrating FloPy with other software, and this FloPy package also work in some other software. Uh, okay, now we will do the practical work. I have given a short introduction of the FloPy. I have given the short introduction of the hydraulic head. I have given a short introduction of the Modflow modeling. Now we are going to see some coding and modeling part for creating a boundary condition of this. Okay, have you any question? Please ask. If any question related to this, please ask. Hello, hello, Mohammed Saidul
No, sir,
Hassan.
it's
Have you any question? Okay. Now here the code is written import OS print OS dot get CWD. What is the meaning line by line? We will meaning of source and sink. Sink means something you are giving and source means something you are taking. Suppose that you are using a pumping set, pumping well, then you this act as a source, groundwater source. And suppose that there is a pond or river, then this act as a sink. Then this is a recharge, and your pumping well is a act as a discharge. Okay. Is boundary condition based on the safe file like study area? Yes, it is defined, but your safe file is just like administrative boundary. Administrative boundary is not considered for this. Basically, a boundary condition is designed for the aquifer boundary. Okay, then we are going to Modflow modeling is used for the aquifer modeling, and your safe file is suppose that your place is Kolkata region, then Kolkata is your administrative body. In Kolkata, there may be a big aquifer which is exceed the boundary of the Kolkata, or inside the Kolkata there are lots of the small aquifer. Then first identify the aquifer, then construct the boundary. Now see here some this one code is written import OS. Import your reserved keyword. I have told you yesterday what is the reserved keyword, and the print OS dot get CWD. What is the meaning of this? We will see line by line each code. Import OS means this line imports the OS module. OS means operating system, which is standard Python library that provides a way to perform operating system depend functionality like reading or writing to the file system, managing paths, etc. Now next is print os dot get cwd. What the meaning of this code? Os dot get cwd is a method for the mo- operating system module that returns a string representing the current working directory of the process, and this will give you the path for your what is your current working directory. The current working directory is the folder in which the script is being executed, or it can be considered as the directory from which you are running your Python interpreter in case you are using an interactive session. And the what is the meaning of the print command? Is a function that outputs the specified message to a screen or another standard output system. Okay, now we are going to run this and see what is the path of my this. The path of this my current working folder directory C user SEMA desktop exe. On my desktop there is a folder is called exe. Okay, and this is my current working directory in which I'm going to install I'm going to modeling for a creating a boundary condition, and there is a Modflow. I have written I have already told you the Modflow is a open source and written in the Fortran programming language. Fortran is a coding is a type of the language, programming language, and originally the code is written for the Modflow in the Fortran, and there is a some executive file, and this is freely available on your Google. Then Modflow, just see when executing for the, and this is, suppose that you are using the Windows, then this zip file is available on your Google. Just search on this executive file, the Modflow 6. Just then you will find this mf.60, mfsim, modflow, and these are the executive file, and directly plug into the my with FloPy module, and then this code will directly work in your Python. Okay, this is the way. You can search. Suppose you just go to the Google and executing file, right here the executing file for Modflow modeling. See, executing the model on USGS file, these are available. Okay, not here. You have to search this thing right here, the .exe. Okay, I will share the link where this will you will get. Otherwise, I'm also sharing this. Just see Modflow USGS model. Okay, not it is content source. This may be on GitHub. Okay, okay, I will share the link, and don't worry about these things. The first things, these are the executing file. Where this exe? Okay, these are the exe, the executive file, modflow and wt64.exe and mf6.exe, and we will use this. How this we can use this in my Python programming, we will see here. I will share this executive file. Otherwise, I'm sent to the uh, web address. You can download from that location. Otherwise, I will share this. And this is freely available. Don't worry about this. Now open the Jupyter notebook. Now come to the this type of the code. Import FloPy. Import NumPy as NP. Import matplotlib.pyplot as plt, model name ex02, and here we are using the mf modflow 2005.exe. This is freely available, and this is save, keep in my folder exe, where at this location. Okay, you have to make a folder and connect this your working directory with you, and now activate these things. Okay, now one by one we will read this code, what is actually it is telling. The code snippet is used to set up a Modflow groundwater model using FloPy, which is a Python package for building, running, and post-processing Modflow based model. Here is the explanation of each line. Okay, the line import the FloPy library into your Python environment so that you can use it to the work with Modflow. This line imports the NumPy library. Now the second for the NumPy library, the numerical Python with the alias with NP. Whenever you use the NumPy, one time it has been activated, import NumPy NP. After then, when you are written the code, NP dot. Okay, then numerical Python has been activated. NumPy is a popular Python library for numerical computing, particularly known for its efficient array operation. And this line import to the matplotlib.pyplt. I'm talking about this. Import matplotlib.pyplt as plt, and gives its alias with plt. Whenever one time you have when you will activate this, then only use the plt dot, then this will work. And this is basically used for the plotting graphs, images, picture. Now, come to here, you define a variable model that holds the name of the Modflow model you are working with. This name will be used saving the model input and output files. Okay. Exe underscore name is assigned the path to the Modflow executed file. Here, this is the path. Already I have making a folder exe mf 2005 this one, and this file is keep in my folder. Just see exe mf 2000. There is another exe file exe. It will be here. Just see this one. Okay. Are you able to see mf2005.exe? This is executive file for the Modflow 2005. This is freely available and written. This executive file written in the Fortran code. Now our aim to plug in with in our Python environment, Jupyter environment with the help of the FloPy package. Okay. Path has been already given, that is the exe, and this name is given. Now come to the next thing. Code is the model underscore ws, and I have defined the sum in string results. What is the meaning of this? We will see. Model underscore ws stands for the model workspace. It is the directory where the model input and output files will be stored, and this folder, when you execute this folder automatically make in your folder. In this case, result is the name of the folder where you want to save or from where you want to load the model files. This line create an instance of the Modflow class from the FloPy library. This instance assigned to the mf variable mf is the Modflow. Okay. It initialize the Modflow model with the specified name, model name. Here just see model name, executive.exe, and workspace model ws. This is the workspace executive file, and this instance mf, that is the function mf, will be for Modflow modeling, will be used to further define and the model parameter run the simulation and process. Now we are going to run this. Okay, it has been executing. Just see it has been executing c user sima app dot roaming python, and this is now run this mf. What is mf telling? I'm telling the Modflow model has been activated. Okay, activate with this, and in this layers, row, column, stress period as assigned. Now we have to give the value. Now we will some read about this code. What is telling this code? The lines import FloPy. We know about this. A Python package is specified designed to create, run, and post processing workflow based groundwater model. FlowPy allows you to interact with the Modflow input and output files directly from Python. Okay. This import the NumPy, come to the NumPy. We have alias with the NP. When after the activating NumPy, then you have to only write np dot and write your desired function and bracket the variable name. Now come to the this third is used for the your, we have already discussed for use for the graphs and this. Now come to this one, import FlowPy units utils dot binary file as bf. Okay, this import the binary file module from within FlowPy utils and gives as a li bf. The module contains utilized to read binary files that are typically output by the Modflow and other related groundwater modeling software. This can include such as heads, drawdowns, or cell by cell budget files. Okay, and this will be more clear. Okay, I'm going to clear how the binary file is working when. We are constructing the grid. Okay, this is your suppose that the boundary, okay, and this is your the grid, okay. This is your grid. Anyway, I'm not good in the drawing, but I'm telling you. Inside the grid, cell is one, okay, one, 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 okay, and this is called your active cell. And outside of the your boundary, this is the boundary 0000. This is called the inactive cell, and these are in the value of the cell, and this is saved as a binary. Binary format is 0 and 1. This one, okay. That's why we are calling as import floppy dot utils binary sbf. And now we have activated the floppy, and that floppy is fused with your mf 2005 dot executive file. Then only write the bf dot and desired function, then this will work. Now the sum, we have defined the sum thing, and what is it is telling, one by one we will understand. First see the code, something import numpy np, okay, and pr and state per len ts mult t ssd jbuild and lay and row and column, create the top array, assign values, and what is these are telling, we will see one by one, because we are working on the dummy data. That's why we have defined this one, okay. Otherwise, if you have a safe file, then you have to define according to your safe file. Okay. This first line is the import numpy np. You know about this thing. No need to this thing. No. Now next is the npr. What is the npr? Here the next thing is the npr. npr is 11. NPR is a variable that likely represent the number of stress period for the model. Okay, we have seen the stress period now. 2.0.1 day, 0.7 day, 2.1 day, 2.3 day. This is the stress period. Here we are taking the stress period is 11. These are in a day, or we will see how define this unit. Basically, this is in day. Variable that likely represent the number of stress period for the model. A stress period is a length of the time over which boundary conditions are assumed to be constant in a groundwater modeler. Okay, because the boundary condition is not a constant. Suppose that aquifer boundary is in 1900, in 1980 covered the 2 kilometer, but in 2024 it's cover only 500 meters. Just why? Just because of the road construction, building construction, aquifer has been damaged. That's the boundary is changed after the time. That's why we are defining the station. Now next is the nstp. What is the nstp? NSTP is a list that sets the number of time steps for each stress period. In this case, there is a one time step for the first step period and 12 time steps for the given next 10 stress period. Okay, that's why it is a 1, 12, and this one 1 to 12, and NPR is 11. If you return is a 12, then you have to return is a step 13, okay, because it is indexing from counting from 0, okay. Now next thing is the t per lane we have defined. Per lane is a 1 plus 365 and multiplied by 10. What is telling this? Per lane is a list defining the length of each stress period. It is in a list. Okay, list is always written in the big bracket. What is the list variable and dictionaries we have seen yesterday? Are you getting or not? If you have any problem during the code, please ask. Okay. Now, per lane is a list defining the. This is the per lane. When you will run this, first I'm going to run, then and generate the some cell below, and write here the type of the this one PERLEN. This is given the list. Okay, here come to the list, and this means the list. This is also list. This is also list. Now, what is the meaning of the per length? We have defined some with number. Per length is a list defining the length of each stress period. Here is the first stress period is one day or other time unit. Okay, here we are taking the day, not other unit, and each of the following 10 stress periods set to the 665 units. It means that this is for the 365 days. Now next is the TSMULT, and it is multiplied by 1.2 multiplied by 10. TSMULT is a list specifying the time unit, a time step multiplied for the successive time step within a stress period. Within a stress period, it is a one for the first stress period and 1.2 for the subsequent ones. Okay, and it goes up to the 10 times. This implies that each time step is 20% longer than the previous time step, with each step stress period is after the first. Okay, because this is multiplied by 10, it's going to one. Now, study is a true and false multiplied by 10. It means that study is a list that indicates whether each stress period is steady state or transient state. If it is their steady state, then it is a true, and transient state is a false. The first stress period is steady state, and the next 10 is a transient. Okay, we have seen Modflow modeling. What is the equation of transient and steady state? Now come to the JBOT. Here it is defining something number minus 50 and minus 100. What is telling this? JBOT might represent the bottom elevation of the two layers in a multi-layer groundwater models. Okay, just see, this will be clear from here. This is the ground surface. This is your bottom one layer. This is the bottom two layer. This is the water level, and this is your bottom of the aquifer. Then we have defined this one is because it is below the groundwater surface. Then that's why it is a minus, and this is your datum plane. Then from height is a minus something, the minus 100, and this one is the minus 100, and this one is the minus 50. Okay, then this define the a boundary of this from top to and datum plane. Two layer we have defined, basically three layers, and we will also define the three layer later. Okay, JBOT what represent the bottom elevation of two layers in a multi-layered groundwater model. Okay, now the dimension of the model grid and lay, the dimension of the model grid, it's a dimension, it's a cells dimension is 3 meter or 4 meter. You have to give the dimension on, and lay for the number of layers, and row for the number of rows, and n call for the number of columns. Okay, we have defined. and lay means number of layers. There are basically three layers is given. Number of rows are present 21 and number of columns presented 20. Okay, because when you assume this in a 3D representation, this when you assume this 3D representation, this is your column and this is your row. Okay, and this is your layer 1, this is layer 2, and this is layer 3. Okay, and this way. Now run this. Finally is a loop as constructed here. No, top. Okay, here after then the dimension of the model grid n lay for the number of layers and row for the number of rows and then column for the number. This is dimension. Now here we have defined top np dot ones and row and column and data type np dot int 32. Integrated integer 32 means if you have a laptop, check the your 64 or 32. This mf executive for working with the 32, that's why is written here. Top created 2D array matrix. It is using for the array matrix 2D with the shape 21 into 20, 21 rows to 20 columns, which we have defined here, filled with the integer value 1. This might be used to represent the surface elevation of the model grid. Okay, this is top. Now we have here construct a loop, that is the this loop assign values the top array. For each column, it assign a value that decrease linearly from 396 by subtracting I star 4. This could be simulating a slope land surface. Okay. As we have defined, and the value we have defined here, the 365 and 3 just give it 395 subtracting. This could be simulating the slope land surface, and this is given a slope land surface for column. Okay, basically taken for this one, 20 multiplied by 21. Now run this, and I'm here writing generate a cell below and writing top. See, a array has been developed in the form of the stress period and basically 0 and 1. Okay, now come to the this code snippet, and what is telling about what is telling this line of the code. This block of code is a part of a script, is a set of the groundwater model using FloPy, which is a Python package for creating, running, and post-processing Modflow based model. Modflow is widely used groundwater flow modeling software. Here is a breakdown to each line code. Okay. Yes, first line is the model underscore ws is a variable that defines the model workspace, which we have already defined. This is directly where the model input and output files will be stored. Okay. Now model name. Here the model name session 3. Model name is a variable that specifies the name of the model. The name is used. And now define the function FloPy dot modflow that modflow and give that all here. Now run this. Now mf function. We have already defined this previous. Now come to the this snapshot code of the snip. What is telling this code of line? Okay. The block code for this, I'm talking about this block code of line. Okay. The block code is conferring the special discretization of a Modflow model using FloPy, a Python package for building, running, and post-processing groundwater model. The first line sets nlay and row and call has a number of layers, rows, columns for the model grid. Respectively, establish a three-dimensional framework with 3 layers, 21 rows, and 20 columns. Okay. Now here they define the top. The next line sets both DLR and DLC 500, which are the width of the each cell in the row and column direction, suggesting that the model grid cells are 500 units square. It's in units square means it is a meter. Okay. The top variable is a set 400 meter, defining the top elevation of the model grid, which bottom is a list that specifies the bottom elevation of each layer with the within the grid descending from 220 to 0. The last line creates a discretization package. It is associated with the model instance Modflow by passing the define the parameters by layers, rows, columns, cells, top elevation and bottom elevation, effective laying out of the geometric structure of the groundwater model within which the flow equation will be solved. Okay, now we'll see the dysfunction. See, we have defined this Modflow discretization package. We have activated one by one. We'll see and the number of model layers that defines one and the integer and this one top, bottom. Eh, Read carefully about these things. Import. Okay. Now we are going to talking about this. Okay. Code snippet. Are you getting this type of the code? If you have any problem in for understanding the code, please ask. Now, the code snip provided defines parameter for a three-dimensional groundwater flow model. I think we have. Okay, now this is the different three-dimensional groundwater flow model and initialize a basic package using FloPy, a Python package for building Modflow model. The first three lines set up the dimension of the model grid, which we have already 32120 we have defined. The number of layers, row and number of number of rows and call the number of columns. The I-bond array, here the C I-bond array is then created using numerical Python, setting all cells into the grid to be actives indicated by ones. Okay, we are only interested in the active cell. In active cell, we have to neglect. That's why we are using I-bond. Use the function np.opens and lay and in this boundary select the only active cells. All cells are active. Okay. Now next is the your meaning that every cell can have its hydraulic head calculated and can conduct flow. The strT array is also creating using numpy. Uh, we are talking about this one numpy full np.full and lay and row 320. What is the meaning of this? We'll see. Initializing the starting hydraulic head 320 units. It's meter for every cell across all layers, rows and columns. And finally a Modflow basic Modflow package, and this is the basic Modflow package defined by the BAS. Install initiating using the FloPy, passing the previously created I-bond and strtrs as argument along with the MF object which represent the Modflow model. The Modflow bus class setup essentially information for the model simulation, including which cells are active and the initial head condition. Now run this and below generate cell and write here the BAS Modflow basics here package activate. Now see, Modflow basic package has been has been activated for your active cells with I1. Okay, and this has been activated. in a binary this one. Now this we will read about this one more. Read about the basic function. In provide the course need the Python library FloPy is important, which is the package design and post processing Modflow based on. Just check me Modflow MFR. This was the same. Okay, this is the same. Uh, Build, run, and post-processing Modflow based on groundwater models after the import an instance of the Modflow base class is created from the FlowPy Modflow module. This intents represent the basics package uh, for a Modflow model, which is used to set the initial condition for a groundwater flow simulation. The Modflow BS constructor is called within the MF object, that is the Modflow simulation object, which is assumed to be an already created. We have already created, if you remember that, we have created here at the here starting. Okay, here see cell number 8 MF. We have already created Modflow layer column stress. Okay, that's why we are using the MF, and inside this function we will create I bond and array of the active cells. Okay, and this will be more okay, which is used to set the initial condition of ground flow simulation. The Modflow BS constructor is called with the MF object, which assumed to be an already created Modflow model. The I bond parameter is set to 1, which is typically is the cells are active and can have their heads computed. The STRT parameter is set to 320, defining the initial starting head for all active cells. The resulting basic package object is stored in the variable basic active package BS, which we have defined here, which can be attached to the MF model object for the subsequent simulation run. The step is crucial for setting up a initial condition necessary for the models of the groundwater flow. Okay, again run. This is the same thing which we have seen. Okay, Modflow basic model has been activated. Now come to the next function. We have defined the LPF. What is LPF? We will see here. And inside LPF, we have written the FloPy. FloPy is a this function for Modflow, and here use the function Modflow LPF. MF function we have defined, in which your array type has been defined, and here HK, what is the HK, BK, and LA type, IPK, KCB 53. We will see here what we have defined this one. Now, the line of code initialize the layer property flow. LPF means layer property flow. Package of a Modflow model using the FloPy library. The LPF variable being assigned an instance of the Modflow LPF class from the FloPy.modflow module, which is used to specify the hydraulic properties of the aquifer layers in a Modflow groundwater model. In the instance of this class, several arguments are passed. MF refers to the model object previously created. SK defines the hydraulic conductivity for each of the three layers of the model grid with values 50, 0.01, 200. VKA specify the vertical hydraulic conductivity also for each layer with values 10, 0.1, and 20, because we have created three layer, that's why this is a 3. Lay type, LAYTYP, just see here, lay type is a list indicating, it is written in the list indicating the layer type for each layer, with 1 for convertible layer where storage coefficient is specific, 0 for confined layers, And IPKCB is the unit number where cells by cell budget data should be saved. 53 in this case. In this case, there are 53. By default, we have taken the trailing BAS to be a typo or incomplete command as the not part of the LPF package installation and should be either be removed or computed with the appropriate. No worry about this thing. This will come. Okay. Now activate this, generate a new cell below the and run the LPF. Here is a Modflow layer property flow package. We have defined, okay, what is telling you and already given the value. Okay. Now come to the RCH. We have defined something RCH. What is telling the RCH? Now this one we will see. The line code creates an instance of the recharge package. Okay, RCS is a defined for the recharge. Okay, for a Modflow model using the FloPy library, the RCS variable is assigned this package instance. The FloPy dot modflow RCS class initialize the RCS package within the border Modflow model MF, which we have already defined, which was previously defined. The argument reached 0.005 sets a uniform recharge rate across the entire model domain. This is by default taken. We assume that uniform recharge is very less and negligible. Okay, which is the rate at which water is added to the groundwater system, assumed to be in units consist with the model, typically length per time. This recharge rate is essential parameter in groundwater modeling as it affects the groundwater balance and is often a critical factor in the simulation of hydraulic levels of the behavioral ecosystem. And this recharges come from your rainfall or pond, river, etc. Okay, but we have taken a very small. Okay, now activate this one and run what is RCS. See, recharge package class. Okay, this is the recharge package class methods FloPy, and this is written in the binary. You cannot understand because it's a computer programming language. You have given these things. Now come to the something we have defined SPD well FloPy modflow well MF stress period and data SPD. What is telling you about these things? Something valuable is written here, and this is written in the list. Why it is written in the list? It must be written. It may be written in the not. It is written in the dictionary. Why it is written in dictionary, not written in list? We will see here. Okay, the code defines a well package of a Modflow model using FloPy, a Python library for building a running Modflow model. The variable SPD is a dictionary that represents the stress period data where the key 0 refers to the first stress period. The associate list contains a single list with 4 elements specifying the well parameters layer to layer 2 row 10 column 9, and a pumping rate is minus 15,000. Negative value indicating extraction is something pumping is pumping process is going on. This data structure implies there is one well in the model at the specified location at which the given pumping rate for the initial stress period. Next, a FloPy package Modflow well is created and assigned to the variable well, passing the MF model object and SPD stress period that as argument. This line effectively added as a well to the Modflow model, incorporating the defining stress period data into the model setup, allowing the simulation to account for the effects of pumping from the well during the groundwater flow simulation. Okay, now SPD basically we want to define a well, and SPD is a stress, groundwater stress, and zero represent the for the one well, and that's why we are using the list dictionary. And this is the your uh, three layer, then the row, this represents the 10 row and 9 column, and pumping rate is this uh, 15,000 unit. Now run this one, and this see the SPD. SPD is a dictionary. Check the type of the this one dictionary type SPD. This is the dictionary. Now we will see the nature of the well. There are three well. We have Modflow well package class. We have defined here the FloPy Modflow. Modflow well here just written here, and inside the MF which we have already stress period and data is SPD. This is well data. Okay. Uh, a matrix has been constructed. Now well plot. See well location 1, well location 2, and well location 3. In 3D view, we can only see the it's a cross sectional view. This is the cross sectional view. That's why we can see the this. But in two side, you cannot see the layer one, layer two well. Now you can know about this things. What type of the model basically you have created a model, and with the help of the FloPy package, and what you have created you can check from here. Now come to this code. Okay, what is telling about this? Okay, we have not taken the river concept. Now river concept has been come because it is very important in the Modflow modeling. Okay, this is the conceptual modeling is going on. Before in Modflow modeling, the first things you have to construct a grid, and this comes to the conceptual model. After then you have to do numerical modeling. Okay, we will see. The first line of code defines a dictionary named SPD underscore RID with a key of 0, which likely represents the stress period number for a mod flow simulation. The value associated with this key is a list comprehension that generates a list of lists. Each inner list represents the parameter for a river package in Modflow applied to a row or of a cell across a specified layer and column of the model grid. The parameter for each river cell include the layer 0, the row index ranging from 0 to n row minus 1, where n row is the number of rows in the model grid. The fixed column index is 19. The stage or river level 320 or conductance 1E5, and the river bottom is elevation is 318. Okay, this has been given. Okay, the second line of the code create a Modflow river package by calling the FloPy Modflow river class construction with the previously created Modflow model instance MF and the SPD underscore array stress period data dictionary. This effectively adds a river boundary condition for to the Modflow model with the specified setting for each river cell distribute along the 20th column 0 indexed and 19, and across the all the rows defined by the row for the first stress period of the simulation. Okay, now activate this. Now it has been activated. Now generate below cell. SPD This has been dictionary. Now RIB package, river stress period. See, Modflow river package class has been activated in a dictionary form. Now plot the river plot. This is the river plot in a cross-sectional view. Okay, this will not visible in layer 1, layer 2 because lateral view you cannot see in a plan view. Okay, now come to this type of the code which we were not going to run, and what is the meaning of this code we will see here. Whenever you use the hash key, then it means code cannot be run. The commented outlines of the code are intended for reading values from a CSV file name. This is basically designed for the CSV file. If you input data, then you can use. Okay, that's why here I written code as in inactive form. I'm using the hash key, and it is in inactive form. Okay. The commented outline the code are intended for reading values from a CSV file named rechargevalues.csv and storing them in a dictionary with the line number as the key. The open rechargevalues.csv read lines statement open the CSV file and reads all lines into a list where each line is a string. Okay, whenever you have input data, then use this type of the code. Otherwise, no, because we are working on a dummy data, then no need to run this code. Okay. Now we are going to this line of the code. What is the? We have defined something SPD and OC. What is SPD and OC? We will see. The provided lines of code related to the specification of output control options in a Modflow groundwater model setup using FloPy. The steady stress period data is a dictionary. Okay, is being defined with keys that represent stress period and time setup tuples. Here 0 indicates that the first stress period first time step. The value for this key is a list of the string specifying what output to save or print during the simulation. Print head to the print head information to the listing file. Print budget to print the budget information. Save head to save the head data of to a file. Save budget to the save budget data to a file. The OC value is an instance of the flow floppy Modflow OC. Yeah, here the C class which is created to manage output control of the Modflow model MF. The stress period data is equal to SPD. Here the C argument passes the output control data where define and compact is equal to indicates that the output should be in compact form. Essentially, this part of the code configures the what model data should be output and saved during the simulation execution for further analysis. Now activate this. Okay, now what is telling the SPD? This one, and this is basically header file, and we have calculated the budget, and we will calculate the these things after the creating the this grid. Now, what is the PCG? What is the meaning of the PCG? The line PCG FloPy Modflow PCG MF in a FloPy script is used to instantiate a precondition conjugate gradient solver for a Modflow groundwater flow model. In this context, PCG is a variable that will store The configured PCG solver object. The FloPy Modflow PCG class is called with MF as an argument, which is a reference to the existing Modflow model object created previously in the script. By adding this line, you are attaching the PCG solver to your model, which will be used by the Modflow solver, the linear system of equation that results from the discretization of groundwater flow equation. The PCG solver is one of several solvers available in Modflow for handling large sparse matrix system and is often chosen for its efficiency is converging a solution for a complex groundwater model. Okay, a method of discretization using for the method of discretization which we have seen in the theory part use the this. Now Modflow PCG package class has been activated and this looks like this. This is in a binary format in the programming language. See. Uh, Many times we have seen this thing, no need to explain this, but here be some map view and line connection is coming. So we will exactly what is telling this snippet of the code we'll see. This code snippet is visualizing a Modflow model grid and a boundary condition using FloPy plotting capabilities in conjunction with the matplotlib, a plotting library in a Python. First, it imports the necessary modules FloPy for working with Modflow models and matplotlib.pyplot for creating plots. It then creates the figures and axis object figure axis. You can adjust this thing using matplotlib, which provides a canvas for drawing the model plot. The plot map view function from FlowPy used to create a plot of the model grid. Now grid has been constructed. Now you will able to see through its visualization. Okay. Uh, Here model grid of the axis with the model instance MF provided as an argument. The plot underscore grid model method is called on the map view object to draw the model grid lines, and plot I-bond is called the visualize the model boundaries I-bond array, which indicative indicates active, inactive, or constant head cells. Finally, plt.show is used to display the plot. This code would typically be followed by additional customization options for the plot, such as setting titles and other things. Okay, now I'm going to run this thing. See, grid has been constructed, which on the basis of your given input data. Now again run same. I increase the size of the picture only here 12. Okay, now okay, adjust this it up to okay. This is okay. Now come to the this. What is telling about this code snippet? This code snippet is a part of the script using matplotlib and FlowPy for visualizing elements of a Modflow groundwater model. The first line initializes a matplotlib figures FIG and a tuple containing two subplots axes AX1 and AX2 arranged horizontally, one row and two columns with a combined figure size of 20 by 12 inches. Map view is then defined as a FlowPy object for plotting 2D map view of the model MF. On the first subplot, we will see the subplot of the in this picture. Basically, we will see the sub cross-sectional subplot. Let's see. See, this is the cross-section plot, and this is your 2D plot, and this is your top view cross-section plot. Okay. Now come to the next cross-section plots of this. Now come to the final this one, taking the MFP and this checking for Modflow executive. Yes, see there's normal termination of simulation. Modflow is run successfully. Okay, now it has been created and okay, we will read about this to understand the each line of the code. The code snip being by importing the operating system module and the FloPy package are necessary for operating system interaction and creating Modflow models, respectively. The exe underscore path is then considered using the path join, which ensure the correct file path syntax for the Modflow executable mf 2005.exe located in a specified dictionary or the desktop for of user schema. Here, this is a file location. A check is performed to confirm the presence of the executable at the given path. If the executable is not found, a message is printed to indicate this. It is found a Modflow. If this executable is present in your folder, then message will show it is running successfully. If not present, then this will show Modflow did not run successfully. Okay. If present, then Modflow runs successfully. Okay, I'm only checking for this. Now come to this. Now main part of this. After then this uh, great concept and boundary condition finish. The snippet begins by the constructing the correct file path for a Modflow head output file which records simulated groundwater levels at each time step. It does this by concatenate the model workspace dictionary model underscore w, the model name, and the .sds file extension using os.path.join, ensuring compatibility across different operating systems. Then it attempts to load the binary head file using FloPy utility function head file, which reads Modflow's binary output. If successful, it retrieve the head data for the specific step, and we will see this file will be saved in your working folder, and how this calculate the head and the budget you'll see. If successful, then this will be the specific head file. If not, the was not found. Head data load successfully. Okay, now come to this. Okay, what is telling the provided code is a part of the script that use the FlowPy Python for building, running, and analyzing Modflow groundwater model. The script being by importing the FlowPy package, it inserts a Modflow model instead of MF specific model name and model W, which we have previously defined. Next, the code set up the discretization package, which defines the spatial resolution of the model grid. uh, it is specify which we have already defined. Now basically this is defined for your model grid. Now checking this your code model grid is initialized. Okay, it is working. Now final, the provide Python code snip is designed to create a visual representation of a groundwater model's cross-sectional data using the FlowPy and Matplotlib libraries. Initially, it is important Matplotlib plotting library, and then establish a figure and a single subplot with a specified size to display the graph. The title heads on cross section is set for the subplot flowing that it utilizes the FlowPy library to generate a cross-sectional plot of the model MF along a specified column line. In this case, the 10th column of the grid. If it then calls plot underscore array to render the hydraulic head data head while executing specified values. Uh, Here the 99 is meaning the NA value, and setting the transparency of the plot alpha to 0 point for the better visualization. If this is a visualization, you can change here. A grid is overlaid on the plot of the reference. Enhancing readability of the visualization. Finally, PLT sort triggers the display of the figures of the cross-sectional data of your head plot. Okay, hydraulic head. Now run this. See, this is the head on the cross-sectional view. Now you are able to see a simulation of the hydraulic head. Okay, this is the three layers of this. Now check the water budgeting system. In go now going to your exe file and results. Go to the results and here the heads. Open with Modflow. Just open with this one notepad. Oh, sorry, LPF will. So, okay, this is the result of your this US journal. Now water budget system is has been given here. Percent discrepancy in and out. You are given the rate is 0.05. So after this out storage 75 and 45. This in this one after stress period, and these are the given here. Okay, this is the result of your output data. Now PCG, check for the PCG. This is the your okay. This is your simulation part. No, only the list is given. Uh, Now we have done for the how to construct a boundary condition and how to simulate the hydraulic head, and we have seen the water budgeting in and out